Hello, everyone. Everyone's laughing. Everyone's laughing at me. Good afternoon, everyone. Welcome to the 147th episode of the Bisimoto Tech Tuesday. You may wonder, what do I have on here? What's going on with Bisimoto? It's supposed to be warm in Southern California, but it is, but a little cooler. But nonetheless, here I am, and I don't know, they're taking photos of me, so I'm gonna take this off. There we go. Okay, that's more like it. Okay. How do I make the D series fast? There's so many things I can share with you. Finland's in the house, courtesy of Hutsia. Good seeing you indeed. Thank you so much for joining me this afternoon. And I'd like to give a big shout out to Errolson and his team out in Germany with Acronym. They were kind enough not only to provide delivery on the 935, but also got me this great attire, which I'm wearing here today, with these cool trousers and all that good stuff. Look at this. And the tennis shoes. And so thank you so much, Errolson and team, and Rod, the guys, for making this happen. I really appreciate you guys a lot, so thank you so much. So let's jump into it. I saw a question came in about how to make a single cam fast. Now, there's so many things to do, so I'm going to share some really good secrets on my D series that can allow you to do that, which is nice, right? So, on a D16, the challenge is, yes it is, DJ Ramarov, it is a Heady Motor shirt. There you go right there. Combined with Acronym as well. So, the key to making power is to get as much air as possible in the engine. And one thing you know about a D series is that it has a limited induction aperture. So the head ports are very small, very limited indeed. So what could you do to make it happen, make a lot of power? One thing that D series lacks is flow. So even if you put next to a B16, same displacement as a B16, but it's limited, right? So porting is extremely, extremely important. That's number one. And the more cross-section area you have, the better. You don't want to bring it to the water jackets because you can easily do that. We have companies like Portflow has helped us tremendously with that, and he knows what to do. Tom knows exactly what to do. Secondly, camshafts. No matter how much flow you get into it, you need to be able to actuate the valves very properly. So that being said, a Bisimoto level X, if you're saying NA is the way to go, a 3.6 if you're going boost. And the camshaft plays a huge role as well. If you're saying NA, one thing that I find very appealing is the fact that if you go with a larger bore, it helps to shroud the valves significantly and creates a lot more power. Just by doing a proper induction, putting the head, valve train, camshaft from us, bigger bore and compression, you can easily eclipse the 180 to the wheel horsepower range, which is very, very simple. So, Trom pistons, go sleeve block to go with bigger bore, all that good stuff. Now, if you're staying boosted, it's even easier. All you have to do is low compression pistons from Trom, proper rods, like a Bisimoto spec rods, Bisimoto level 3.6 or 2.4 cam if you want more enjoyable idle, and boom, that's it. Nice turbocharger. You can do something as small as a 48 millimeter. You can go something as big as a 64. You can easily make anywhere from 380 to north of 750 horsepower to the wheels, which is great, you know? So I have so much going on here. This is a project. I have a client's car there, another client's car there, client's on lift, another client's car on lift, black NSX right there. I even have this project I need to work on. This is something that a lot of people really never, ever see. This is a Tesla Roadster. That's also a client's car. I have to take care of my customers first before I even play around with my own projects. Unfortunately, I'm not one of those selfish shop owners. I have to do it. So clients first, and when I get these projects done, because I really miss racing a lot, I would get to the inside. But right now, my clients who keep the lights on, the doors open are my priorities. So forgive me, please. Can you build me an F22 for like 1,000 horsepower? Yes, it can be done. Actually, the F22 lends itself very well, F22A, non-VTEC, lends itself very well to 4-digit power. And you may say, why, BC? Well, the head flows amazingly well. When you look at the ports on the F22A, they have huge potential for power. And the one thing that Honda did to really make it very tame is by putting very small, very conservative camshafts in them. So if you throw some camshafts on that, those engines, the F28s come with 8.8 to 1 from factory, so it's low compression already, so it lends itself to boost already out the gate. But if you want to make 4-digit power, you definitely have to sleeve it, get some of the rods we have. We have a long rod combo, long rod and piston combo for 1 millimeter oversized than factory, which is 86 millimeter. The head, which has the highest potential for power on that F22A, flows more stock than most ported B series. And you know what B series guys do? They There's so many 1,000 horsepower B series out there, it's crazy. It's just that in the Honda world, which is something that always shocked me, people tend to not think out of the box, which is pretty interesting. And by not doing that, we don't see a lot more creativity. A lot of people tend to copy each other. So since there are not a lot of people who tend to copy the single cam thing, I guess it's not popular. We did D series and people jumped on that. But I never really built a boosted F22A. And if I did, I'm sure people would jump on that as well. But nonetheless, there's a good opportunity to have some fun with that engine. It's really just one of the, if not the most underrated performance engine from American Honda, or from Honda period, you know. Gusta Silva, 100 from Brazil. Thank you so much for joining, sir. I appreciate that indeed, you know. Would you say that the Veloster N kind of fits where the Focus ST used to be? Rest in peace, Focus. I would say yes, Cobalt, but it is a superior vehicle. If you drive a Focus ST and drive a Veloster N, the Veloster N has a very strong European, almost BMW feel to it, and I'm not surprised because engineer Bierman is now head of the N division, and he took a lot of that BMW DNA from how the vehicle feels to the pop and bangs on the D-cell, just the engine smoothness. It has a lot of BMW European DNA in it. So I would say, yes, it could be a good replacement, but an upgrade, I would say, from the Focus ST. Hello, Jarok Pablo, good seeing you. Yes, he's right, Fox Design is correct. They're dominating the GT Racing Series in the Veloster, they absolutely are. Thank you for the feedback, says Danny B. My pleasure indeed, sir. Can't wait for you to make my boxer hot top. Thank you so much, Secret Service AP. Your box is gonna be really clean when it's done. Who makes the collecting rods, be it steel, aluminum, or titanium? Who would you recommend? I have quite a few local machine shops that do stuff for me because I don't machine in-house. If you're looking for aftermarket ones that I've had success with and my customers have had success with, I've seen customers have success with everything from R&R, especially on the aluminum side, GRP. We've even had success with that as well. There are quite a few. Titanium I've not used. Titanium tends to gall to metals close to it, so I tend to shy away from that, even though you can coat the offending surfaces. I tend to see a lot of NSX's guys come here with modified factory titanium, but I'm purely steel and aluminum. And for all my prototyping, I use aluminum, and also for any of the drag motors where I can have a lot of power, and I'm trying to use something that acts like a very nice shock absorber. And that's the cool thing about aluminum rods. When you detonate, God forbid, but when you do have this like preignition, it doesn't easily transfer it to the crankshaft. It actually absorbs a lot of it. So you see a lot of top fuel dragsters, that's all they use because they just couldn't use steel. The steel would disintegrate itself or destroy the crankshaft very, very badly. So aluminum rods are like these great shock absorbers and also can act as a variable compression device. You're like, what the hell do you mean by that, BC? Well, aluminum has a very high expansion rate. So because of that, when you put in an engine and it's cold, you definitely want to give a decent piston to head clearance. So I have engines anywhere from 50 to 60 thou piston to head. You know, on regular engines, or you may have steel rods, you can get away with maybe 30 to 35 thou piston to head, but you want to go 50 to even 60 sometimes piston to head on aluminum rods. So when you start up the engine, it's easier on the starter, the piston sits below deck quite a bit, and as it warms up, the aluminum expands and the compression gets higher. It's pretty freaking cool. I'm going to be running a turbocharger kit on my F22B on VTEC Honda. Very nice. You will notice though, as you look at that F22B2, the exhaust ports, being that the two are closer to each other and the other ones are kind of farther apart, tend not to flow extremely well. If you do have the capability, upgrade or slightly backdate your head at least to an F22A, A1, A4, A6, you will not regret it. It's an amazing head. Just noticed no hat. Yes, D-Ling, I have no hat on today. I was actually rocking my jacket, but it's kind of warm. I have this Acronym jacket from Germany that Errolson and his team was kind enough to send to me. This jacket, guys, is pretty crazy. Do you know how much this jacket is? This jacket right here is really cool. It's $3,500. This is a pretty penny, very expensive jacket. It's absolutely beautiful, very tactical. And the materials are, they're very like futuristic, really cool. And the trousers, you see my trousers here? It's really, really nice trousers. But yeah, I'm not wearing a hat today. And I think I didn't wear a hat a couple of weeks ago as well. So, yep, and I got my little Bisimoto shirt on, which is pretty cool. Thank you, Bisimoto. Bisimoto, should I supercharge my E46 motor? I want more power, but keep thinking that my 8K was all built to be NA. So that's a bit of a misnomer, JDM agent. The RPM limit is based on so many factors, and as engineers, we tend to design engines to keep in mind the safety, reliability, and we give a cushion there. Valve train plays a big role. Camshafts plays a huge role. Bore stroke ratios play a big role as well. So all those combinations are ideal. You could, if you size your turbocharger properly, you could stay within that boundary and still be a turbocharger. Supercharging is also very nice as well, especially since it allows for an opportunity where there's absolutely no lag whatsoever and your vehicle will feel like a bigger displacement naturally aspirated setup. So that being said, supercharging is actually quite appealing for something that we're just trying to do. But the one thing about supercharging that I kind of have a little qualm with is that you cannot limit power easily based upon vehicle speed or gear. So let's say you make on your E46, let's say you end up making 600 horsepower. That 600 horsepower exists whether in first, second, third, fourth gear, whatever the case may be. But in turbocharging, I have the capability based on electronics and boost control using a wastegate to keep it at 250 horsepower in first gear and 300 in second gear and then ramp it into 600 in fourth and higher. So you have the capability of having this great modular setup, which makes for an enjoyable ride. But just like natural aspiration, you can do the same thing. You can just have fun, have a ball with supercharging. And many times you don't have to worry about exhaust manifolds and heat rejection to the engine bay and all that fun stuff, you know? Is there a cost-effective way, says Rod Motorsport, to measure my air-fuel ratio? Wide bands are too expensive. I'm quiet because my good friend Rod Motorsports is not aware of what we went through back in the day, I guess. So, not too long ago, and I'm talking about less than 2 decades ago, if you wanted to look at your air-fuel ratio, you had to have a very expensive Horiba setup, or you had to have something very clever from Motec. And on the Horiba side, an air-fuel ratio monitor was $21,000. A Motec cost-effective small gold box was still about $7,000. And nowadays, we have AEM wideband sensors for $150. It's pretty cost-effective, right? $200. So tell you what, Raw Motorsports, what I could do to help you out is I do have, it's an inline though, so you'd have to be able to have a way of logging it. But if you're doing this with an engine management solution, send me a DM. I have a used inline wideband sensor that I pulled off my blue Porsche that I'm not going to use. I'll sell it to you for like $80. I'll just sell you the whole thing. So let me know if you're interested. I'll sell it to you, and then for $80 you can have an inline wideband system. So I have it right there in the corner from my blue Porsche. But there's no other way to bypass spending, you know, little north of $150 to get a wideband sensor. It's just, right now, it's a very cost-effective device. And if you think about the circuitry that goes into it and what it analyzes and how important this is to tuning and also the precision, it's a pretty cost-effective, good route to explore. So hopefully I can help you there by sending you one of the ones I have here that I'm not using. You're super good at building cars, says I'm sure 2021. I want to go back to Master Mechanic School, UTI College here at ICOM. Well, good job. Please do that. Please pay attention because I've had some great guys from UTI. I've also some guys who have no idea what they're doing after graduating, which is interesting. But I'm also a huge advocate of someone going to a 4-year university and studying mechanical engineering. So if that's within the cards for you, we need more creative engineers. We really, really do. It's almost like a lot of creativity is going to some of the tech colleges, but we need creative engineers, not the ones who just go to school and stay within a box. We need those engineers that think crazy like I do and think out of the box and make things happen, you know? Hey, Bishi, says Akura Shell. Called me Bishi, interesting. Anyway, I generally heard that modifying cars reduces reliability. If you made a high horsepower car but detuned it significantly, could it match OEM reliability? So, great question, and I will answer that for you properly. Any good tuner or builder worth their salt would tend to do that. So one of the reasons why this van was built in 2012 and keeps running until today, one of the reasons why my project in my own race car can go season after season after season without a rebuild, is because what you want to do as a proper engineer is to test the limits of the power plant and the combination and back off like a good 30%. Hence, give you that reliability. And that's something that the OEMs do quite well. And that's something we learn from them. It's only people who are very foolish that will push an engine to the very edge and expect it to be reliable. It just can't. There are stressors, things happen beyond your control. And mechanical devices do have limits. So when we do failure analysis, we haven't done a lot recently, but I used to do quite a bit at my old facility. It was a clever way of saying we get to blow things up on purpose, just to see how far we can push things before they fail. And then we back off a good 30, that's a magic number for OEMs and even for myself, a good 30%. And that way you can drive the car for extended periods of time, for hundreds of thousands of miles without any challenges. So yes, it can be done, but it comes in design and tuning. And by the way, with tuning, you can mess up a 90 horsepower setup with a bad tune. So component-wise, yes, it can happen. And people have done that, you know. Thank you for talking about the fit. So it was NA, that's wild. No, the 400 horsepower fit was boosted. It was, I used a Turbonetics, I think it was a 54 millimeter turbo, if my memory serves me correctly. But I built two. So I had if you see, I had the white one with the kind of crazy Mugen-inspired stripes on it. So that was like a nice track club racer spec build. And then I had the blue one with the cage, and that was full all out. So we did a couple of those, you know. When building an engine for the manufacturer, do you build an engine from scratch or just match existing engines from the car and then rebuild it? Is the Odyssey J35 and Fit L25? L25. Anyway, we have done both. We've had the opportunity where manufacturers have given us a clean slate, but that happens very rarely. Most of the time, a manufacturer will give you an existing engine and want to get to technology to improve that to a second generation. And it's more cost effective for them, especially if you can stay within the mold construction of the outside of the casing and have some small adjustments to it that can make it much more reliable and much more efficient. That's what they prefer. So yes, both has happened. And the Odyssey, the engine, yes, was a J35Y, and on the Fit, it was an L15 factory casing. Even though you have a thriving business, would you ever consider joining F1 or a WEC team? I would if the opportunity presented itself. Absolutely. Those guys are on the cutting edge of everything motorsports and technology when it comes to automotive. And it seems that a lot of them are concentrated in Europe, especially in the UK, which is sad. So I used to go to UK quite a bit because that was like the mecca for me, going to an Autosports show. It's almost like a center of the universe when it comes to everything in motorsport. But ever since I discovered CES, I've been skipping on going to the NEC, which is quite sad, you know? Would you let your daughter race once they become older? Yes, Texas Hold'em, I would. My first daughter, she's almost 8 years old, and I wouldn't stop her from doing that. My son, who is going to turn 3 very soon, he's just crazy about cars. I won't be surprised if both of them get involved in motorsports at some level, you know? Yes, big block single cam, that is what the F22 is known of. I see you, Kevin, what you're saying. Shame on you. Kevin, unfortunately, I cannot ignore my customers to build my race cars. It's just not a good use of my resources or time. And short of me cloning myself, it's really tough. It's tough. And it's so sad I could even build it, and I probably won't even have time to race it. So I do have to take my customers first, unfortunately. Have you worked on Coyotes? What are your opinions on them? Well, I haven't, but I have one right over there. So there's a Coyote engine over there. I just recently received, and Marvin, one of the fab guys here, he's helping, actually it's really his project, I'm helping him with it. We just received, and thank you so much. I mean, I think of Ford Performance, I reached out to some of my contacts at Ford, and none of them could help me out, but then Von Gittin Jr. was kind enough to help me, so I have a ECU pack up front, which allows for full control of the of the engine, the transmission, comes with a MAF, a pedal, map sensor, all the good things, just get something started on the bench. So we're gonna try that and throw it in an old school Ford truck, you know? What happens if pistons are installed in a car incorrectly? Very bad things happen. So let's say the most common ones that I've seen from facilities is if someone puts the intake side on the exhaust, hence the exhaust side is not on the intake. With the interference motor, you tend to see the valve contact the piston because of like a relief. If there is an offset pin on a setup, and that's also happened, you can get increased noise on that as well. If you're talking about a ring package, that is just something really bad happening, you know? William Payne 16, have you ever considered making an EV917K? Yes, I have, but I've not had access to be able to do one yet. If you have one you want us to do, let us know. We bet at Auto Club Speedway on the weekend of 19th. I didn't know what's happening. Let me know, DJ Ramiroff. You know? F22B, what engine is that? Please explain. F22B2 is from Accord. It's like a later generation Accord. I think you can find them in 97 Accords, to be exact with you, and up. What I tend to use is like from the older Accords, 1990, 1992. And I think with the newer Accords, there was a lot of more emphasis on efficiency and fuel economy. And that was the case with the older 1990, 1991 engines. So the F22B2 is a newer generation of the F22A out of the Accord, known as the CB7. So I hope that helps. Hello, Agu, double O, good seeing you. Andy Rocha, thank you so much. Hello, and Andy Rocha, I see you're from Brazil. Thank you for joining me indeed. Do you think I can get away with just running a 93 on a 13-to-1 comp K24 ITB street setup running on Infinity or 12.15 max? So that's a great question, and the answer is yes and no. And you say, why? On the 13-to-1 compression, yes, you can run it, but on stock cams, I doubt it. The one way to cheat running a high static compression is by really reducing that dynamic and by running cams that have a lot of overlap. So I've done that with great success. I ran really high compression north of 12.5 on my street car while I was in college, daily driven, on 91 octane, not even 93. And I had success because my camshafts are huge. And what happens is you tend not to get to a point where you have preignition. My timing was very low. You don't be surprised if your peak timing exists in like as low as in high RPM 19 to 19 before top dead center. Don't be surprised if you heard the high teens or low 20s because of the compression. But running a big cam is the way to get around it, and your car will just wake up. It's amazing what you can get away with compression. But bear in mind also your tuning window is very narrow, and that narrow window can be expanded further if you have a field that's more, how should I say, anti-knock capable, like KRS is saying here, KRS F30, if you run E85. And with Infinity, you have the capability of running flex fuel. So if I were your shoes, here's what I would do. NA setup for 91 octane, or 93 in your case. Tune it with the big camshafts, and you will be able to tell the knock limit. If you look at the tuning window, especially in Infinity, you can do a knock window from 0 to 50 degrees, monitor it, and keep it. As a matter of fact, after your first full runs, build a knock floor, so that if you ever exceed that during your runs, the ECU will quickly add fuel and retard timing to keep you safe. Then, when you get to that knock floor, and you get to the best tune on 93, with your flex fuel sensor in your return line, and connect it to the input for your AM Infinity C, tune on 85, and you'll pick up a ton of power. Interpolate those two results for ignition timing, and also you want to adjust your fuel ratio for lambda as well, and then you're good to go. So you can now have your cake and eat it too. That's what I would do, and that's what I've done for a lot of clients. What's a good fuel filter for E85 B18 turbo? AEM actually makes one. They make an element filter that's very good for that. Kinsler also makes a complete stainless one as well. So you have those two options that I've had success with, BC knows so much about combustion engines, says D-Link Designs. He built an EV to start learning again. That is absolutely, you're 100% correct. And I learn weekly. Even this week, I'm learning about immersive technology when it comes to thermal control with batteries. So every week, even this morning, I was reading about that and writing to some companies using this 3M liquid that allows for a non-conductive cooling mechanism for batteries. And it's fascinating stuff. I love it so much. So yes, I'm learning quite a bit. Will the Rose become your new daily driver? How much do you pick up for, says Kovo. Kovo, I'll save that for a conversation I have with you. But don't be surprised. Don't be surprised if it does become my new daily, Door types, electric versus cable, says Jason Emily. Ooh, good question. Cable is what we've used for eons. And it's pretty straightforward, very easy to access, very easy to implement any kind of strategies for repair. Even if you're doing something as silly as cruise control, you can just grab the cable and hold it in a position and cruise control works, which is pretty cool. What are some of the things I don't like about a cable? If you want to be able to change around your ratio of your pedal versus the throttle body opening, you have to do some very clever cantilever items of control or have a very lopsided shape on the throttle body, and it's not adjustable. On the other hand, so for example, let's say you have a very lightweight vehicle. Let's say you have a Caterham 7 or even, what's another good one? An Area Atom. And you have a boosted Area Atom or boosted Caterham, and you have this cable throttle, and you have a very decent sized throttle body on the engine. Well, if you step into it barely, air can open up quite quickly because many times the throttle has a 1-to-1 ratio from throttle position to aperture on the throttle body. You can have a runaway session where you step on it and it just jerks on you. It's not very controllable. And then you have an idle control valve, which could also be another boost leak situation. So what I do in all my cars, even the wagon right here next to me, I convert it to drive-by-wire. All the Porsches I have, air-cooled or not, drive-by-wire. I'm a huge drive-by-wire fan because I can remove the idle control valve, which is a leaking point, definitely will boost that engine. It's just one more port that can leak. So get rid of that. I can use drive-by-wire to be able to do really clever things with traction control, with cruise control, and even most importantly, using AM Infinity. You can also do this with Haltech Elites, you can have the opportunity to have a ratio of pedal versus throttle body. So I can open up, I can command a 10% throttle position, and it'll only open 3% on my throttle body. I can go to 20, I can open to 10. I can have complete control of that ratio. So once again, to my previous example, small car, big power, big throttle body, I can now easily drive into it and have it feel normal. Or you see some of the newer cars now, right, where you have some kind of sport mode and eco mode and normal mode. Those are, if you do power runs on those, they're typically the same, but the ratio of the throttle body is something different. So you can use drive-by-wire to do different modes. Earlier versions of throttle body systems had a bit of lag, but nowadays with systems like AEM Infinity, it's so quick. It is, you don't feel any lag at all. It's absolutely non-existent. It's fantastic, you know? Oh, so many great questions here. Oh yeah, let's go. Yeah, I just answered that. Thank you so much. My pleasure indeed. Favorite front-wheel drive platform? Honda CRX HF, because it's lightweight, very simplified, and has a lot of aftermarket support. On a newer version, of course, on the inside, because it's very cost-effective, full aluminum. One of the few cars that American Honda lost money on every time they sold one, and really gave me the majority of trophies I have in my office, which is amazing. If you had to pick one car for daily track use, what would it be and why? Ooh, that's a good question. So KRS-One F30, I will share this because I just shared it with a client last week. Believe it or not, it would be the Acura NSX NC1, the newest Acura NSX. That is a supercar that you can go out with your girl, literally, to a beautiful restaurant when restaurants open up. So it's very elegant, very exotic looking. Has a reliability of Acura that you can have come to love and explore. Has amazing support from the aftermarket community, especially from us and from companies like SOS. And above and beyond that, on the track is absolutely fantastic. We are drag racing, the electric motors. I mean, we're running consistent 7.1s at Irwindale here, which has been quite a few cars because you have the electric motors in the front, you have the single electric motor in the rear, and acting as an integrated motor assist between the engine and gearbox, which is absolutely fantastic. It's a great car, and it's one that's not very common. So you don't see them very often. So the Acura NSX, the new one, is the perfect car. And then I actually went to shopping at a Vaughn's locally, and I couldn't believe how much I could fit in that rear trunk area. It's amazing. I had a case of bottled water, I had a bunch of fruit, I had bread, I had milk, I had orange juice. The thing actually, it was pretty cool. And people don't even know what they're like, oh, when is this coming out? I'm like, it's already out, sir, or madam. So that would be, if it's one car for daily and track use, that would be it. Now, I couldn't carry an engine in it easily. This is a D series block, I could probably carry that, but like today, I went to go Nigo with the H23 block. I don't think I'd be able to fit that in comfortably. But apart from that, it's a great car. Dealing with design, can you explain what pre-ignition is, please? Sure. Just like the name implies, ignition happens prior to when you want it to. Anyway, no, I'm being a little too simplistic. So, you guys have heard everything from the auto cycle, where you have ingestion, then you have compression, then you have explosion, ignition, and then you have exhaust. So the key to making power is, of course, getting as much air and fuel in the right relationship into the engine as possible. But when the piston's on its way up, you know when that spark plug glows and creates that explosion that then pushes the piston down? You don't explode that right at top dead center, not right when the piston comes up. You want to explode that a few degrees before the piston goes to the top. So as the piston's on its way up to the top, you ignite it, and then the burn happens because it kind of forms a plume, and then pushes out of the piston, which then does work. And then that allows the crankshaft to turn, which in turn is connected to your clutch and your transmission. Anyway, great things happen. Something really interesting also happens if you do not ignite at the right time. So if you retard it so much to whereby the ignition happens much earlier, you won't have an efficient burn. If you have it too soon, you can have too much of burn. If you advance the ignition so much, you can have opportunity where you can have like some very damaging effects. It's almost like igniting when the piston's on its way up, which is not very good. So, pre-ignition happens in many ways. It can happen with too hot an intake air. Let's say you have an intercooler system that's not ideal, or on a very hot day. If you have too much high static compression, or your dynamics is extremely high because of your camshafts. Do you guys remember what we talked about last week, where I said, talked about Charles' law in physics, where when you compress a gas, the temperature goes up? So imagine having a physical high compression dome and you're compressing the gas. You can get to a point where prior to igniting, the compression is so high that the air temp in there gets so high that it can self-ignite the fuel in there, which is a problem. Preignition can also happen when a spark plug electrode is too hot and can ignite it. It can also happen if you have sharp objects in your combustion chamber, like a protruding head gasket, sliver, or even a very sharp point in your piston dome design. It can also create preignition. It's pretty much we're igniting it prior to when you want to, or in a time that is not ideal. And that's typically very damaging to a piston. I'll tell you how damaging it is. It's akin to you taking a piston and hitting a hammer on top of it. Because preignition can cause detonation, and the detonation is very, very damaging to your engine. Now, engines can take some of it, but it cannot take it for long. You hear like little tick, 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 which is pretty bad. But guys, you know what time it is? It's 12:57. I'm gonna get kicked out of Instagram any second now. So thank you so much for joining me on this 147th episode of Bisimoto Tech Tuesday. Once again, thank you Bisimoto for the cool shirt. Thank you Acronym for the amazing jacket and trousers. And look at these shoes. These are pretty cool kicks. Look at that. Very nice. So thank you so much. And thank you for all of you for being great advocates of our program and for all the manufacturers for allowing me to live my dream through their amazing stuff. Envious Productions, shout out to you. Thank you so much. See you next week. Stay safe, everyone, and God bless. Take care now. Cheers. Bye-bye.